Alright, so we'll look at how to drive adiabatic work or adjust adiabatic formula. Right, work under adiabatic. So we need to know that so this is physical chemistry. Alright, so it can be studied by these guys who are taking this. So let's go. So under adiabatic, what we need to know, we learned about isochoric, adiabatic, isothermal, all those stuffs. So so we are talking about adiabatic, right? So we need to know that under adiabatic, dq is equal to 0. All right, there is no change in pressure. So say it's d0 like that. Okay, then what we will do is under adiabatic, work is given as the integrated form of where we have 2 there, okay, then 1, then we'll say p dv. Okay, so this is how work will be given under adiabatic. So from there we need to know that under adiabatic, p and v, okay, from gas, ideal gas equation, they will be given as constant, meaning that if I have p1 p2, I name this one as p1, then again v1, then it's constant, so I'll produce even at the same, using the same conditions, I'll produce p2 v2 gamma. All right, so from there we can see that getting the second one, the first one, it will give us the constant is equal to p1, all right, then v1 gamma, meaning that from our equation now, w is equal to the integrated form of 2 with those limits 1, then p dv. Okay, so now we can make p the subject of the formula. So say p is equal to, or let me just do this, we'll say pressure 1 v1 gamma is equal to constant. All right, or let me just say, without even naming 1 I'll just put we can lab this at this point because we are not comparing to anything. So what I'll do, I'll say I can make, since p is constant somehow here, what I'll do, I'll say p, okay, is equal to constant over volume gamma. Okay, so I'll go substitute there. So I'll say the integrate form of where we have 1 to 2, then we are replacing now p wherever there is, so we are replacing here, so that will be c over v gamma, then dv. Okay, so from there, then what you are going to do, say work is equal to the integrated form. All right, then before that, let me just so say since c is constant, so I'll say c constant, the integrated form where we have 2 to 1, then we'll just remain with 1 over volume gamma dv. Okay, so from there what you are going to do is, we'll say work will be given as constant, the integrated form of 2 to 1, then since it is now over, I can write this as v, all right, minus gamma, then dv. All right, so integrating this form now, how do we integrate? So we know to say w is given as c, all right, integrating this v to the power gamma, we'll add 1 there, and the same thing that you do, we'll do also. So I'll say integrating this one, I'll say we have v, all right, minus gamma there, then plus 1. The same thing I've done here, I'll do what? I'll say negative gamma, all right, then plus 1. Okay, then dv. Since I'm integrating now, this was related to v, so I can now leave the dv. Okay, Okay, now leave the dv. So these are the limit we have, 2 to 1. Okay, so now from there I can just rearrange this equation to say w, which is work, is given as constant, then the limits now. So I can say, since I have volume there, then I have negative, so I'll just say 1 minus gamma. All right, I've just rearranged, so that will be 1 minus gamma, then with the same range, 2 to 1. Okay, meaning that there are two things here. So I'll say work will be given as constant. All right, then I have volume 1 minus gamma, all right, over the same 1 minus gamma, then minus, since there are two, this one will hold 2, then the other one will just hold 1. So here I'll name it as 2, all right, volume 2. Then here I'll say volume 1, then 1 minus gamma over the same 1 minus gamma, then I end like that. So what I'll do, I'll say work will be given as constant. Now coming to constant issue, I'll say so I'll say constant will be given, we said c, all right, will be given as p. Since c is constant, p, I can say p1 v1 gamma, all right, which will be equal to p2 v2 gamma, like that. So I'll choose, all right, so I want to distribute this constant here, so that will be c times the same volume 1 minus gamma over 1 minus gamma minus the same volume, so this is v2, then this is v1, 1 minus gamma over 1 minus gamma. So what I'm going to do is I'll get this c where so this c also supposed to be there because I've distributed inside there. So from there now I'll substitute this, since this one is having v2, I'll say I'll have two c's, so the first c will get this one, the second c will get this one, right? So there I go. Then I'll say work is equal to, so this c that I have there, I will substitute this with 1, volume 1. So I'll say that c is equals to p1 v1 gamma, all right, then times, since I had times here, so I'll say times v, wait, this is for v2 because I have v2 there, so this is for v2, then 1 minus gamma, all right, so over 1 minus gamma, then minus this c there that I have here, I'll substitute with the one related one, so I'll say p1 v1 gamma, all right, times the same v1 minus gamma over 1 minus gamma, like that. Okay, so from there then it's just a matter of now simplifying. So I'll say work will be given as, so we can see now I'll just say p1, I'll get one volume because they are same, which is v2, and also this p is p2, by the way. Okay, so then we can see I will just get powers, so I have gamma there, all right, plus 1 minus gamma, all right, then minus, by the way, there is over 1 minus gamma. So here also same, I have p1 v1, I have gamma plus 1 minus gamma, then over 1 minus gamma, all right. So what I'm going to do here is I'll say work will be given as, so you can see now gamma and gamma goes, and also gamma and gamma goes, so I'll only have p2, all right, p2 v2 minus p1 v1, all right, over, since this is just common denominator, so I can just put them as 1 minus gamma. So this is the work under adiabatic. So this will be given as, it is just after you are done this, you can even show to say nRT, all right, then over, all right, the same 1 minus gamma, then you can put dt or just change any temperature. So work can also be calculated given this equation. It is just equal to, so you can write this equation. So this is work under adiabatic. Otherwise, that was it.